All right, vertical motion is actually physics. So we're jumping into physics a little bit here. And I know a lot of times y'all ask me, when will we use this in real life? Well, boom, vertical motion is really where we're going to start using it. So the equation for vertical motion is h of t equals negative 16 t squared plus vt. And then this plus the constant is going to be the starting point. So I'm just going to put c for constant starting point. So the v over here, the negative 16 is always going to be negative 16 t squared, and that's because it's the curve of the earth. V is for velocity. And then once again, c is the starting point. So are you on a platform that's 50 feet above the water? Okay, well then your c would be 50. If you're standing on the ground, the c would be 0, and so forth. Another thing, every single time you start one of these problems, I immediately want you to draw your parabola, your U-shaped graph, and up here is your XY, and then down here is your XY. Now, this X is always going to be time, and Y is always going to be height, right? So this is going to be your max, and this is your 0. This should be nothing new from what we've been talking about. So if you're 0, your y over here is always going to be 0 because that's the height, right? That's how long it took to hit the ground. So every single time, we're going to find these 2 points, and you're going to find x, y, and whatever this is, x0. And then you're going to go back and read the equation. So let's talk about that right now. So number 1, a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation is there. Gives the height of the ball after t seconds. All right, so before we even start reading what they want us to find, we're going to find these 2 points. So x and y and something 0. All we do is we plug that into our calculator. So negative 16 x squared plus 90x. So grab your calculator, second quit. Y equals negative 16 x squared plus 90x. And now we're going to graph it. And I actually have my, sorry, let me fix this real quick, guys. Turn your stat plot off, because I know from our last lesson we had it on, so just turn it off. And then we need a zoom 6. All right, now we're at the standard. All right, so there is our parabola. And I know some of you are like, wait, what is this? So you can remember, you can zoom out as much as you want. So zoom out 3, enter. And you can keep zooming out if you really want to see that max point. It's up to you. Zoom out. So 3. Let's try it one more time. Let's see what happens. See, so now you really can't see it. So let's zoom in 1. Zoom in. All right. Okay, so our max point is somewhere up here, right? And then here's our 0. So if we want to find that max, remember it's a frowny face. So second calc, we're going to find the max. So 4 left, we go to the right, which means we're just going to keep on going until we see our little spider come to the other side. Enter, enter. All right, so our maximum point is 2.81. And the y value there was 126.56. 126.56. 126.56. All right, now let's find our 0. So we go back to the calculator. We're going to do the same thing. This time we're going to find our 0, which is here. So we just found our max up there. Now we're going to find our 0. So second, calc 2. We need to go to the left, which means above. So push enter. Now we got to go below, which, look, my y's are in the negative, so that's definitely below. Enter, enter. So my 0 is at 5.6, let's say 3, 5.63. All right, so remember, x is always time. So this is going to be seconds, and then that's going to be height. Y is always height. And so if they were talking about feet, so this is going to be feet. All right. And let's go ahead and put it in. So find the maximum height of the ball. This is the max. The height is always y. So the maximum height of the ball is 126.56 feet. How many seconds will it take for the ball to reach the ground? Boom. Here's the ground. The green is in seconds, so 5.63 seconds. Done. Number 2. An apple is launched directly upward at 64 feet per second from a platform 80 feet high. So look, here's our velocity 64 and the platform is 80 feet high. The equation for this apple's height at t seconds after the launch of blah, blah, blah. Now I'm going to make mine like this, not a complete U, because look, the apple was launched at 80 feet above, right? So that's the only reason. But we need to still calculate the max and the 0. So here's the max, here's the 0. Okay, so we have 2 points. And that's always going to be 0 right there. All right, so let's go ahead and put that into our calculators. So go to your calculator, go to your y, clear it out. Negative 16x squared, what was it? Plus 64x plus 80. Plus 64x plus 80. And now we can graph it. All right, so let's actually zoom in a little bit. It's kind of crazy. Now remember, this time, look, the first side is over here because the y equals, remember, the y is starting over here at 80. So that's why our y-intercept is 80. So let's go ahead and make this, we can actually go into our, what's happening? Oh, it's still thinking. If this is happening up here, guys, so you see how that's like moving? That means that the calculator is still moving around, calculating. So what I do is I just say second quit because you know me. Well, let's just turn it off for a second. Really? Okay. All right. So go back to your zoom. Let's zoom out. So 3. Why did it not zoom out? Okay, so I was a little impatient, but here we go. So here's our graph. So let's find the max, which remember the max is going to be somewhere up there. So let's go ahead and go second, calc, max. When you go to the left, which it is, so push enter. Then we keep on moving till we're definitely to the right of our vertex. So we're definitely to the right now because the y's are in the negative. Push enter. So my maximum point is, I'm just going to say 144. So 2 seconds, 144 feet. And then I need to go, and then now we need to calculate our 0. So go back to your calculator. Second, calc, we need to find the 0, which is 2. Left bound, enter. Now we need to go right, which means below the or the x-intercept. Enter, enter. So our 0 is at 5, 0. Remember, if this E shows up, that means it's a tiny number, which is just 0. So don't be stressed out. So that's 5, 0. So 5 seconds. All right, now let's read the questions. Find the maximum height of the apple. The maximum height, and the only height really that we have, is right there, that y value. So 144 feet. How many seconds will it take for the apple to reach the ground? Well, here's the apple traveling. It hits the ground. Boom. So 5 seconds. All right, that's it. One more. In science class, the students were asked to create a container to hold an egg. They would then drop this container from a window 25 feet above the ground. Now, the reason that we don't have a plus t here is because they dropped it, which means there was no velocity. I'm not going to ask you that, but just, so you have a little bit of information. So if there's no velocity, if you drop something, then the v is going to be 0, which means you don't have a t. But you still have the t squared, right? Because it's always negative 16 t squared. And then the window is 25 feet above the ground, which is why we have that plus 25. All right, so let's go ahead and make our, this is 25 feet above, right? So we know our maximum height's going to have to be at least higher than 25. All right, that's immediately what we do every single time. Let's go ahead and plug this into our calculator. Clear negative 16x squared plus 25. Let's graph it. All right, so we want to find the max height, which is way up here. So let's go ahead and say second, calculate maximum for. It always starts on the y-intercept, if y'all notice that. Look, x is 0, y is 25. So you can always push enter. And then now we need to go to the right, which shouldn't take us long because the 0 does not look like it's that far over. So our maximum is 5.38. I don't know if I did that right. Let's try it again. Calc, max. Okay, enter. Oops, I don't know why I put second, sorry. Right bound, go over, definitely to the right, enter. Oh, you know why, guys? Oh my goodness. That E means 0, right? And then Y is 25. So if we're dropping it, of course that's the maximum height. Duh. So this is our maximum height because we're going here and we're dropping it, right? So our max height is 25. So let's just go ahead and move 25, and that's at 0 seconds. So 0 seconds, 25 feet. All right, now how long it takes to drop. So really, if you just take this off, it's going to go down this way, right? How long does it take to hit the floor or to hit the ground? We go second, trace. We're going to find our 0, which is 2. Left bound, enter. Now we just have to make sure our y is going to the negative. Enter, enter. And that's at 1.25. So that's at 1.25 seconds. All right, let's read the questions. Find the maximum height of the container. Maximum height, 25 feet. And how many seconds will it take the container to reach the ground? Boom, right there, 1.25 seconds. Now, they didn't ask in any of these practice problems, but if they asked us how long did it take for it to reach its maximum height, we would say this is how long it took. But I don't think any of them actually asked us that. Okay?